Okay, everybody. So, which is the idea of polar versus non-polar? It comes back actually to a trend we learned about in unit unit 3, I think it was, of electronegativity. Okay, where electronegativity is the force at which one atom's electron, or one atom, pulls on another atom's electrons. Okay, I think of electronegativity as a tug of war. Okay, these atoms are bonded, they're sharing their electrons, but sometimes one of them pulls more than the other. So it's what we would call an unequal sharing. Still being shared, but it's just not shared equally. So this is going to answer the question here and Caleb had with this idea of where are these charges coming from. So when I look right here, so this is a model of HCl, okay? As a Lewis structure, I would just have this line drawn between, so they're bonded together. Okay, the line represents 2 electrons. But those 2 electrons are not shared equally if the bond is polar. What causes it to be polar is because Cl has a much higher electronegativity than H. The way we know that is you go to your periodic table and the trend goes from the bottom left to the upper right. The closer they are to fluorine, the stronger they are in the tug of war. So since chlorine pulls harder on its electrons, you could visualize here, like if there was like this line represents 2 dots. These 2 dots are really hanging out more over here than they are over there. It doesn't take them away, it's not ionic, but it pulls them towards itself because of its higher electronegativity. Now, what charge do these little electrons have? They're negative, okay? So I'm going to draw. So draw this arrow with me underneath or above. So draw an arrow showing chlorine's going to pull the electrons towards itself. Since the thing it's pulling is negative, the other side of the molecule is going to become a little bit positive. So we make like a positive tail on our arrow. This is known as a dipole arrow. It helps show polarity of saying, hey, this side of the molecule is negative, so you want to keep in mind it points to the negative side, and this side of the molecule is positive. That's the idea of the magnetic charge, is if you have a positive side and a negative side, you've created something like a magnet. Now, I want to clarify here that I say like a magnet. Water is not magnetic. Right? Like water does, you can't pick up water with an actual magnet. But it has charges, and so it can behave like a magnet. So keep in mind, don't be deceived by these models. Like, they're not truly magnetic, but this is the best way we can model it to show the idea of charges do attract. Okay? All right, the second way we can model this, so on your homework today, we're going to model this to identify its polar and nonpolar by drawing what is known as the electron cloud. Okay? Go ahead and go into your box, and I want you to pull out the pink and the blue marker for you. Now, I apologize. I bought highlighters because I thought they wouldn't bleed through the paper. These highlighters definitely bleed, so they're not the greatest. I think next term I might space out your notes so you can use them more without it like bleeding through. Okay, we're going to use, so pink is going to be for the negative side, and blue is for the positive side. Okay, so what I'd like you to do is with your blue one and your pink one, so this side is the negative, so you're going to draw like a fuzzy little electron cloud showing this side is negative, and then
I'm colorblind, help me kid. Pink and blue, what was pink? What was pink? Pink? Oh, wow.
he said, and if 2 other colors were better.
Okay.
He's lying.
Oh, he's lying.
Oh yeah, never believe anything.
Okay, everyone have that drawn? Okay, come to the next one. So that's a polar molecule. So maybe write that
I
about
see
it.
in black
So
and
polar
white.
molecules are going to have one negative side and one positive side. The difference here is when something is not are different, right? So if they're not all the same, if they're not symmetrical, it's going to be polar. Or if it has lone pairs. Okay, so an example of this one is CHCl3, where 3 of the sides are Cl's, but 1 of the sides is H. So that's what we mean by this symmetry of it, right? It's not symmetrical because 3 are 1, but the 4th is a different one. Or the other scenario we mentioned is having lone pairs, such as in water, right? They're not drawn in this sheet, but they would be up there, is where they would be. Now this one's not on your notes, but we'll do more practice. But just to show you the idea of the red and the blue again, or the pink and the blue, right? Is that this side is the negative side, we'd see a pink cloud up here, and then a blue one down here. Right, which is why when the water sticks to each other, if you grab your models, can you get a red to stick to a red?
Yes.
Try it.
Fran, are you sure about that?
Right?
No.
And can you get a white to stick to a white?
Oh, you can get it.
Can, right? Because the red side is negative, the whites are positive, and opposites attract. Okay? Okay, let's do it now. Okay, so for non-polar molecules, here's how the difference is going to look with our picture. Okay, come to this model's on your notes, so come to this one with me, okay? So the difference with a non-polar molecule, everybody, give your attention here, is you can still have a tug of war going on, right? That these ones are pulling away from this one. But the tug of wars cancel each other out. And so when it comes to having one positive side or one negative side, you don't get that. In a sense, if this is all being pulled this way, so remember, grab your pink one. So the pink is showing where the electrons are being pulled.
Pink or red?
Right? So you have negative all around, and in a sense, the positive is like here in the middle. Okay? This is going to be non-polar. Because in order to be polar, think of like north and south pole, you have to have one pink side and one blue side. If it kind of ends up being like a donut, where it's like all one way and in the middle, then it's going to be non-polar. Because all of this tug of war has canceled each other out.
Blue or
Because
purple?
polar molecules are going to have one pink side and one blue side, not kind of mixed together. Okay? Okay. Questions on that so far? All right, let me pull up.
Is the fact that I'm colorblind in one eye seem like they're weird?
Okay,
Because you're
if
treating me
it's
like
not
an idiot.
out, go ahead and pull out your homework
The
packet
fact that
for
I'm
me.
colorblind
We
in
didn't
one
put
eye and
any
one
example problems in the notes, so I want to do a few of them with you on your homework.
Colorblind in one eye. That's not how it works.
Pull out your homework and turn to the page that says
I'm an
visualizing
anomaly.
polarity.
We can't be having it on here.
And I want you to go to the back
Why?
side of
Because
it
I'm
first.
different.
Okay, go to the back side of this homework with me.
Casey, you know what you should do?
So visualizing polarity, but the back side. Let's start there and then we'll go to
I'm just kidding. There's no respect. I was purple's what makes it blue. Did you do the extra credit?
No.
Did you do anything? I should have finished this. I
Yeah.
didn't even finish the first one.
Okay, we did the first.
Alright.
We did that. We did that last week.
Yeah, you gotta say monkey, but monkeys aren't colorblind, are they?
Now we gotta Google it.
Can monkeys? Hey, let the record show the kid has his phone out at 8:47 and 3 seconds.
color vision among New World primate species is surprisingly variable. So some do, some don't.
So he's one of them.
Okay,
He's one of them.
looking on the back side here, we're gonna do a few of these together just to give us some practice, and then we'll have you try some more. Now, with today's homework, being that we kind of lost today on Friday, we're trying to like get everything in, but I didn't want to rush our understanding of topics. So on today's homework, there's going to be a column on both sides that you don't do yet. We're going to learn it next time, but so don't cross it off, but you don't need to do it. So it's the very last column, I think on both sides, where it says IMF's present. You just want to make a little note to yourself, like don't do this column yet, because we haven't learned what IMFs are. But if you don't do any of today's homework, then you're going to have a lot more next time, because most of it is the drawing and the polarity. So if you do all of that, finishing the other part will be very quick next time. Okay? So just don't do the column that says IMFs. We're going to do everything about polarity, but just not the IMF side. Okay? All right, starting on the back side, so we're going to look at the molecule CO2, sorry. Okay, so it's already given you a picture of it. Okay, so first step, what's its 3D shape from that image? Linear, so write that on that line.
It's non-polar.
Okay.
Jason's 5.
This color is yellow.
Actually, you're. What color is your eye?
Purple.
You didn't even look at it.
My fit, I can see
So
it.
here's what
My
you need
fit's
to
never
do.
matched.
You're touching everybody. Here's what we need to do with each of the images, okay? So when I check this, I'm going to be looking for colors as well. If you don't have colors on it, you're not going to get full points.
Why color?
Okay? Now, you technically, I'm okay if you don't use red or blue, like if you don't finish it, you do it at home. As long as you just tell me what color is positive and what color is negative. Okay?
What is it?
Alright, so here's my model. Do this with me, ready? So, step one. Okay, so the goal here is we're wanting to know if it's polar or non-polar, and then if it's polar, you need to show me the negative and positive. Okay, so first step, check for lone pairs. Does this not have lone pairs on the middle?
No.
Nope, okay. So the second thing we check for if it's going to be polar is asymmetry. This one is perfectly symmetrical, right? They're both oxygen. And so this is going to be non-polar. So for this one, we don't need to color anything because there's no positive or negative side. So go ahead and put non-polar in that box. And then we'll go on to the next one. Okay. All right, let's come to water. Now we kind of already know the answer of if it's polar or not because you've been playing with water molecules. But let's walk through the process. Okay, so first off, what's the name of this species? Bent. That means quite bent. Okay. Does this structure have lone pairs?
No.
Yes. So on this side of the paper, everybody, because it's showing you the 3D models, lone pairs are ghosts, and you can't see them. But we know if it's bent, the only way it's bent is because of the lone pairs. So keep that in mind. On this side of the paper, the lone pairs are actual ghosts, and you won't be able to see them. But by the shape, you should be able to predict they're there. Okay, Oliver. So now, because it is polar, we need to color it. Okay? So in this case, which one wins the tug of war between O and H?
OH.
Oxygen. Once again, the farther to the left and up wins the tug of war. So we're going to, in essence, our arrows are drawing in this direction.
The purplish looking one or the green?
Yes. Yep, higher electronegativity wins the tug of war. Yeah, good reminder, yeah. Okay, so draw those arrows on your paper in like a pencil. Then, with your two colors, so which side's going to be negative?
I love how pencils are blue.
The top, because the arrows point to the negative.
That's what I said.
And then the bottom, add that to your picture.
He's calling sweet. He's gonna be so
There
crazy.
she is. He's always
questions on how I identified as a polar and how I drew my colors.
I identified that.
Why did you do that? Why?
I identified as colorblind.
Negative.
Negative. Why is
So the
that?
arrows pull
Oh,
to the negative side. Because oxygen is All right.
Which is a lot.
Questions on that? Now, just to show you, we're obviously drawing just like squiggly lines, but let me show you on here what it looks like in terms of like when a scientist actually can detect this. Okay, they used red and blue for their colors. I used pink, so you can have a red one. Right, so you can see here, right, so this
It's purple and
shows
green.
that electrostatic potential going on with our water, right? And notice, like, so if I rotate this in 3D space, right, so a polar molecule is always going to have a very blue side and a very red side. Versus, let me bring up our CO2 again. So carbon dioxide here. So notice that this one, the outsides are red and the inside is blue, so that doesn't make it polar, because you need a distinct red side and blue side to be polar. Everyone see the difference there, where this one is kind of like spread all around in the end. Okay, let's do one more together and then I'll let you work on it and I'll help as needed. Should we do one more on this side?
You should do all of it.
I'll do the other side.
Is it full?
Let's do one on the front side just to see the difference. So flip it over to the front and let's do one of those there.
I have an F on me. I might as well just cross that out.
See exactly what
Okay? Alright, give me your attention for just like 2 more minutes and then I'll let you get to work, okay?
Purple.
So on this side of it, your first step is you do have to draw them. I'm going to kind of just do the first one just to get to the polarity side. So if we do the first one, so nitrogen comes with 5 valence. So 1, 2, 3, 4, 5. There's 3 hydrogens in it. So 1, 2, 3. Hydrogen comes with how many valence? Just 1. So add 1 little dot. Okay, so bond it, connect dot to dot, dot to dot, dot to dot.
That works.
Good, so this one's done, right? So we have 3 bonds, 1 lone pair. Okay, so we don't have to do it on this side, but in 3D space, what shape would this one take? Yeah, this one's trigonal pyramidal. Right, so it looks something like this here, where you have the pyramid, and then that ghost is up top. Yeah.
On this page, are we doing colors?
So we're gonna do colors on this one as well. So is this one gonna be polar or non-polar?
Polar.
How do I know? It has a lone pair. Lone pairs will make it to polar, right? So this one is polar, so now let's color it. What's the negative side and which one's the positive side?
The negative side is
Good, so nitrogen wins the tug of war, right? So you should have like
literally.
pink up top, blue on the bottom, that's your polar molecule. You don't have to do the arrows, mostly I want to see the colors. You can do the arrows if it helps you to know which way. What I'm going to be looking for is
Yeah, but I did not use a rainbow.
Here it is in our simulation, right? So see the red. Okay, any questions that we didn't answer that people still have about identifying if something is polar or non-polar? All right, if you could put your model sets back in the bags for me, I'll come around and pick those up. You have 10 minutes to work on your homework right now. You can work on the front side or the back side, both have to be done, so you pick. But until there's 1 minute before the bell, to get your engagement points for today, I need to see you working on your homework, okay? All right, let me know if you have any questions. I'll come